Okay, welcome to lesson point 3. Sorry that this is getting out to you guys so late. We're going to be talking about quadratic equations in this lesson. Most of this should be review from Algebra 2 for you guys. There might be some factoring techniques that are new or slightly different from how you're used to. I'm going to show you my approach to factoring, which is often called the guess and check method. But if you have a preferred method for doing it that gets you to the correct answer, I really don't care how you choose to factor, just that you have figured out a way that's efficient for you for factoring. And if you feel like your factoring technique is not efficient, then we can work together and come up with another way for you to factor. Okay, so let's get started with quadratic equations. So one thing that I'm going to kind of use interchangeably, so a parabola right here, that's going to be a shape, right, a curve, that if you graph a quadratic, then you're going to get a parabola from it. So parabolas and quadratics kind of go hand in hand with each other because all quadratic equations, graphs are parabolas. So there's a couple of forms for parabolas. We have the standard or general form. And now this form doesn't tell you a whole ton of information. These three coefficients are, used, they're just real numbers. So if you look at it, you're going to say, well, I could just plug numbers in and find points that way, but it's hard for me to find where, it crosses the x-axis. And maybe where this point at the top is, which is called the vertex. But let's go ahead and see what we can figure out from this form. So these three numbers, a, b, and c, they're just going to be real numbers, or real numbers. Most of the time we're going to deal with them being integers, which is nice because it's going to let us factor more easily. But if they're not integers, it's still a perfectly good quadratic equation, still a perfectly good parabola, right? Okay, so one thing we can do is if we plug 0 into this, let's see what happens when we plug 0 in. So this is going to go away, this is going to go away, and that's going to give us c. And so our point when x is 0 is going to be 0c. And this is the y-intercept. That's going to be where it crosses the y-axis. So it does tell us one piece of information. Graphically, it's going to tell us where it crosses the y-axis. Another piece of information, I'm going to go ahead and erase stuff up here. So another piece of information we're going to get from this is kind of which direction this parabola is facing. And it all comes down to this leading coefficient a. So a is the leading coefficient, leading, because it's the biggest, it's the coefficient for the highest power of x, coefficient. And, coefficient, there we go. So a is the leading coefficient, and if a is greater than 0, that's a positive number. So here's a being greater than 0. You're going to get a parabola that's curving upwards. Okay? And if a is negative, so that's less than 0, you're going to get a parabola that curves downwards. Okay? So that's all a is going to really tell you. The bigger the number a is, the steeper that curve is. So I guess it's going to give you that information as well. But mainly, just know which direction this parabola is going to be flipped. It all comes down to the sign of a. So, okay, let's look at the next form, vertex form. This one is a handy one for telling you where the vertex is. Remember I said the vertex is this point where it's either kind of at the top of the parabola or where it's at the bottom. It's the kind of point where the parabola stops curving and it's just gonna bottom out or hit the top of the hill. So From this form, we can actually read off what the vertex is going to be, and the vertex is HK. Vertex is the point HK, okay? We'll see why this ends up being the case, why that's the vertex. Note, I want to add one more thing, that this A is actually the same A as that one up there. So this form will help us kind of sketch the graph of a parabola. It's going to tell us where that top or the bottom of the parabola is. So this would be the point HK up here. One thing I want to add about this is that all parabolas, every single one of them, has a line of symmetry. And a line of symmetry means that if you reflect this parabola, kind of if you do its mirror, you flip it across the line of symmetry, then you're going to get the exact same picture. So, you know, this would be what it would look like if we reflected it across that line at H. It's going to give you the exact same picture. And so the vertex tells us what that line of symmetry is. We can say the line of symmetry is x equals h. So this tells us where that symmetry is for a parabola, and all parabolas are going to have it. They're all going to have vertexes. They're all going to have lines of symmetry. So that's a kind of important feature for parabolas. Okay, let's look at our last form, and this is factored form. Factored form is another nice form that is going to give you more information about the parabola. Again, one thing to note, A is again equal to this A up here. So again, when you know that leading coefficient, you see it appearing in the vertex form and you see it appearing in the factored form. Factored form is going to tell you what the roots are of the parabola. So these numbers R1 and R2 are the roots. And people often call these zeros as well, zeros. And they are, in fact, telling you where this parabola crosses the x-axis. So R1, 0, this point, and R2, 0, that point, are the x-intercepts. X-ints. So they're telling you where it crosses the x-axis. So kind of combining all these pieces, all these forms together, you're going to find that you'll get basically all the information you're going to need to sketch a graph of a parabola. So the here's our factored form. Oops. Here's the factored form, and we're crossing at R1 and R2. So, and the order that you call them doesn't really matter. Just note that we cross this x-axis in two places. Okay, I'm going to give you a second to think about it. Are you able to make a factored form for every quadratic equation? So, can you always factor a quadratic equation? You always get it into this form. So the answer to that question is no. So you can't always get a factored form. And you can think about an example. So here would be an example. I'm running out of space on this slide. So, you know, y equals x squared plus 1. This is an example of a quadratic, you know, where b is 0, c is 1, and a is 1. That doesn't factor. And you can think about why it won't factor, because this is our parabola. Is that thing going to cross the x-axis? The answer is no, right? It's above the x-axis. It's going upwards. It's never going to cross. And so this doesn't have a nice factored form. Later on, we'll find that you can actually factor x squared plus 1. You just have to allow these roots, R1 and R2, to be complex or imaginary numbers. And when you do that, then you're able to factor x squared plus 1 and factor other quadratics using complex numbers. But in general, if you have these be real, then you're not going to be able to write every parabola in factored form. Okay, let's look at an example. Let's figure out what the equation of the parabola with vertex 1, 1 containing the point 3, negative 5 is. So we know what the vertex is, and we just need to find the equation. We know the vertex, and we know a single point, so let's try to find the equation. So we know the vertex, we can use vertex form, which is the ax minus h squared plus k. Let's plug the vertex in for h and k. So here's our h value. It's going in there. And here's our k value. It's going in there. Let me get that green back. And so when we plug h and k in, that's going to give us this equation with an unknown a in it. And remember, x and y, those are our placeholders for points. So x would be an x coordinate, y would be a y coordinate for points that are on this parabola, just like for points on a line. Okay, so we know this point. We haven't used this piece of information yet over here, right? We haven't used the 3, negative 5 yet. So let's use that piece of information. We'll plug it in for x and y and use that to solve for a. So with 3 plugged in for x, there's the 3, and negative 5 plugged in for y, there's the negative 5. We can solve this equation for a. It's going to give us just numbers with a, so it's solvable. So let's just go through the math a little bit here. This is going to be 2 squared plus 1 and 2 squared. So that's, a times 2 squared. So that's going to give us a 4a on the right plus 1. And on the left we have minus 5 still. And so if we take away 1 from both sides, take away 1 over here, take away 1 over here, that's going to give us this equation here, 4a equals minus 6. And then lastly, we'll just divide by 4, and that's going to give us a equals negative 6 over 4, which is just equal to negative 3 over 2 after you reduce that fraction. So there's our a value. So we know a, we know h, and we know k, which are the 3 unknowns for the for our vertex form. And so that's going to be our equation. Just plug those 3 things in. So here's a, there's a, that's our vertex, 1 and 1, and that would give us the equation. So let's go ahead and check Desmos and see that this actually satisfies satisfies our requirements. Oh, wait. To get out of pen mode, here we go. Pen mode, escape. Let's click on Desmos. Okay, so if you notice up in the upper left, this is the equation that we came up with. And then I'm just checking to see that it's going through those points in question and that this point is in fact our vertex. So there's the point 1, 1 up at the top. That's the vertex, and it's actually going through that point 3, negative 5 down there, so that's great. Okay, so that's how we can easily check our work with the graphing calculator. Okay, let's look at another example. Let's figure out the equation of a parabola whose roots are given, 1, 0, and negative 2, 0, and it's containing the point 3, 4, so it's going through a third point. So we basically have 3 points to work with. We've got 3 pieces of information to find, so we should be able to figure out this equation. Okay, so we know the roots, which means we can use the factored form, which looks like that, right? A times x minus r1 times x minus r2. And we'll plug in the values for r1 and r2 that we know because they're given to us at the top, right? We have this is one root, that is another root, so 1 we can plug into r1, and negative 2, you can plug that into R2, and then that's going to leave us with one thing we don't know, which is A. So there's our equation now. Y equals A times x minus 1 times x plus 2. So we've satisfied this part of the parabola. Now we just need to figure out, alright, how do we get this 0.34 involved? Well, if we plug 3 in for x and 4 in for y, we know this equation has to be equal, so we can use that to find what A is. So we're going to plug our 4 in. So there's 4 going in for y. And we have 2 places to plug the 3 in, because we see x appearing 2 times. So everywhere we see x, we're replacing it with the 3. And then that's going to give us a single equation with just numbers and a in it that we can solve for a, similar to the last one. So let's just see how this will shake out. We've got a 2 here, and we've got a 5 here. So this is 2 times 5. And then there's an a in front of all that, so it's a times 2 times 5, which is 10a. So we have 2 times 5, which is 10, times a, which is 10a. Now we divide both sides by 10, and we have 4 over 10, which reduces, if we divide the top and bottom by 2, to 2/5. So that would be what a is equal to. And so, you know, there's our final equation. We know a, we know one of the roots, we know the other root, and so we've got all the information we need for this equation. Y equals 2 over 5 times x minus 1 times x plus 2. And let's go ahead and check our work. We want to plug this equation in to Desmos and then see if these 3 points are actually on it. So let's just check that real quick. So there's our equation, 2/5 x minus 1 times x plus 2. And when you need it to intersect the x-axis at 1, 0, and negative 2, 0, and look, and in fact it does that. That's good. It's projector mode. And then we have a third condition, which is that it's going through this point 3, 4 over here. And you can see that that point is on the parabola, and so we've satisfied the condition. Okay, let's talk about how you might go between the different forms for the parabolas. You know, you've got your standard form, vertex form, factored form. They're all telling you different pieces of information about the parabolas, like where they cross the x-axis, where their vertex is, and so forth. We'll first start off with the easy ways. If you wanted to go either from factored or vertex or factored form to the standard form, then this is just a simple distribution and combining of like terms. So you distribute using, you know, your FOIL strategies, FOIL, and then combine like terms, and combine like terms, and so that's not the, you know, most interesting way of going about this, but it's going to work. And if you want to go possibly more interesting is how do you go from, say, like standard, if you want to go from standard form to vertex form, you want to determine what the vertex is. Notice a strategy for doing this is called completing the square. And I don't believe you have seen this in Algebra 2, so this will be the first time you're seeing this strategy, but it's a good practice with algebra and reasoning, why completing the square works, and it's also in fact the way that the quadratic formula was determined, was by completing the square. And then we'll talk about completing the square in a later lesson. Then if you wanted to go from standard to factored form, this method is just factoring, you know, using your typical factoring techniques. And if you have a preferred way of doing it, I kind of don't care how you factor as long as you arrive to the same answer as everybody else. I'm going to show you the strategy I use for factoring, which is kind of a guess and check method. But if you like, I don't know, there's this box diamond method that exists out there, and these other ones. So you kind of use whichever one you prefer. And if factoring doesn't work, you can always resort to the quadratic formula. Quadratic formula. And we're going to talk about the quadratic formula in the next lesson. There's not a whole ton to it. We're going to work through where it comes from. As I said, completing the square is where it comes from. And then kind of how do you use it, how do you simplify the radical, and so forth. We'll look at it in the next lesson. And then lastly, if you wanted to go between, say like from factor to vertex, there's actually a kind of visual trick. There's a trick to get there. Like you're going to be able to determine the x-coordinate of the vertex pretty easily, and then from that you can find the y-coordinate. But if you wanted to go from vertex to factored form to find the zeros, you actually kind of have to go the long way and distribute into standard and then factor it like you would to go from standard into factored form. So it takes a little bit more work to find the roots if you know the vertex of a parabola. Okay, let's look at an example where we try to find the x-intercepts of a parabola defined by the equation y equals 3x squared minus 6x. So you want to find the x-intercepts, which means you're interested in finding the roots. Just want to remind you guys that the x-intercepts, oops, let's get blue. So this is another word basically for the roots of the parabola. Oh, that's very messy. Apologies. Okay, roots of our parabola, of our quadratic equation. So we're going to convert it into factored form by factoring. In this case, hopefully you see that there's a common factor between both of these that can be factored out, and that common factor is 3x, right? So there's 3x. 3x squared is divisible by 3x, and minus 6x is divisible by 3x. Both of them are. So we factored it out this way. At this stage, I would always encourage you to double check your work by distributing back in to see if it is in fact equal to what we see above. So let's just go ahead and do that. 3x times x minus 2. So when we multiply each of the terms inside the parentheses by 3x, we're going to get 3x times x, which is 3x squared. And then from the other one, we're going to have 3 times minus 2, which is minus 6x. And so that is in fact what we started with. Those are the same thing. And so we factored it correctly. So to find the x-intercepts or the roots, we're interested in, what will make each of these factors equal to 0. What x value is going to make these factors equal 0? So to do that, we set them both to 0, and we solve. So if we set 3x equal to 0, that's going to tell us that x has to equal 0. That's one of our roots. If we set x minus 2 equal to 0, then that's going to, if we add 2 to both sides, it's a short step here. Add 2 to both sides. That's going to tell us that x has to equal 2. So we have 2 possible values of x where we're going to get 0. So we have 2 roots. Our x-intercepts are going to be 0, 0, and 2, 0, based off of that. Okay? All right. So this brings us to factoring quadratics techniques. So how are you going to factor quadratics? I've kind of got a checklist or order for how to go about this. Some of you guys like step-by-step operations, so I'm going to try to run through all the steps that you would want to do when you're trying to factor a quadratic. So your first step should always be to try to factor a greatest common factor out. So GCF stands for greatest common factor. That's what we did on the last one. So greatest common factor. okay? The biggest number that goes into all of the terms you see. And then you also would want to factor out a -1 if the leading coefficient, LC is standing for leading coefficient, that's the A term, remember, coefficient, this is A. If the leading coefficient is negative. And the reason why I like doing this is because it will make the rest of these rules make more sense and always work, as opposed to sometimes working, sometimes not working. And you can always do this step. You're never not allowed to factor out -1 if you want to. So you can always factor a -1 out if you want. Okay, next you want to try to determine the signs of the factors. So when you've got your factoring, you're going to say like x plus something, x minus something. This is what I mean by determining the signs. So these guys down here. Actually, let's not make it look like plus or minus, but instead make it be different. So plus or the minus, or if you've got, maybe it's x minus, x minus, x minus. It could be minus and minus. It could be plus and minus, plus plus, etc., etc. So try to determine these signs. I always set it up like this as your next step. And they depend on the constant term. If the constant term is a positive number, so for example, y equals x squared minus 3x plus 2, here's our constant term. If that's positive, then you're either going to get a plus plus inside, so you're either going to have a plus and a plus, or you're going to have a minus and a minus. That's because these guys are going to multiply and give you the constant term. And so you need a positive answer, so you can get a positive answer here by multiplying two positive numbers or multiplying two negative numbers. Either of those are going to work. And if the constant term is negative, if it's a negative constant term, then they are going to be opposite signs. One's plus and one's minus, and that's the only way you could get a negative. Over here is if one was positive and the other was negative. Okay. Now you're going to try to list all the factors of the leading coefficient and factors of the constant term. So these are the possibilities for what are going to go. Let's use purple. Okay, these are the possibilities of what are going to go here and here, and also what are going to go here and here. So we're listing out all the possible things that we could put into these purple circles, numbers that we're going to put there. And we just start testing. This is our guess and check method. So this is guess and check. If you have another method, then you might skip this and do your method. But I'm going to just show you how to test them, and you're going to be doing a lot of mental math when you do this approach. So it's a good practice for quick mental math. And then you want to check your work once you've, while you're doing your testing, that it actually gives you the quadratic. And when you're done, hopefully if you're checking your work each time, then you won't need to do a last check, but if you really want to, you can. But this is kind of, you're going to just keep going back and forth between steps 4 and 5. You test a pair, you distribute, see if it's equal. No, you go to the next pair, see if it equals. No, you keep going, and eventually you'll get there. And you'll hopefully start seeing patterns with the numbers, why one way, or if the middle term is small, what that tells you. If the middle term is big, what that tells you, and so forth. Okay, so there's patterns that exist here. Alright, so let's look at an example of factoring in practice. So let's determine the roots of the quadratic y equals -2x squared plus 4x plus 6. So in this case, we can factor the greatest common factor which is -2, out first. So you can see everything is divisible by 2, and as I said earlier, we can always factor a negative sign out to turn the leading coefficient positive. And so we're going to do that in one step. So we're going to factor -2 out from every single thing. So we're dividing all the terms by -2. That's what factoring is. And so that should give you this expression now, this equation for y. And let's just double check that that's actually in fact equal to what we started with up above. So how do I double check? I distribute -2 times x squared, oops, 2 times x squared minus 2x minus 3. And when we do our distributing, that's going to get us -2x squared plus 4x plus 6 after doing multiplying on each term, which is what we started with. So good. So that is in fact equal. Okay, now we factor the simpler quadratic that's left, x squared minus 2x minus 3. And we look at the constant term, so that's, again, so this is negative right here. And so we know that the signs have to be opposite. So we can just set up our factoring and then leave space for us to put numbers in to test to see if it's correct or not. So just to double check that this works, x times x, that's going to give us this x squared term up here. And we have a positive number times a negative number. So we have positive times negative over here. And those are going to give us this -3 constant term when we are to distribute. So we have only a couple possibilities we can test here. We have factors of 3 and 1. Well, factors of the leading coefficient are 1 and 1, so there's nothing to test with the leading coefficient. Factors of the constant term are 1 and 3, so we have a couple possibilities, and we're going to test each one until one works. So if we put a 1 here and a -3 here, then again, let's just see that that actually gives us -3, and it's true if we multiply those together. And let's see if we do our cross multiplying, the cross terms, if those are going to give us -2x. So here's the other possibility. You can see we could have put a 3 here, and a 1 here. And that's also going to get us -3 when we multiply. But let's test the first one, see what happens. So we test by distributing. So we're going to get x squared plus x from this guy minus 3x minus 3. And then there's still that factor of -2 out in front. So we combine our middle terms, and we're going to get a -2x minus 3, and then x squared in front. And you're going to see that this is what we were looking for. That right there is what we wanted, which is the distributed version. So we actually don't need to test this one because we found the answer already. So -2 times x plus 1 times x minus 3 is the factored form of this guy. Oops. Let's go ahead and clear this off over here. And so that's going to tell us what the roots are. Here's our answer. We have y equals -2 times x plus 3 times x minus 1. Oops, excuse me. Sorry, it's the other way. Other one of this. X plus 1 and x minus 3, right? X plus 1 and x minus 3. And so we need this to be 0, and we need this to be 0. And so it should be plain to see here that -1 is going to make this 0, and x equals 3 is going to make that 0. So those are our roots. And let's go ahead and take a look at Desmos to see to see if that's true or not. So there's our original equation, negative 2x squared plus 4x plus 6, and we're going to see what its x-intercepts are. Negative 1 and 3 are the x-intercepts, and let's just check that that's what we had earlier. Yes, negative 1, whoops, negative 1 and 3 are the answers that we got. So they they match up with the graph.